Hi, I'm Zihao Wang.
Hi, I'm Hemanth Itte.
We're Team Secure Bytes. We chose encryption and description program as the idea for our group. Both me and Hemanth are interested in the topic. We implemented an agentic encryption algorithm called ChaCha20 and we enhance it with randomizing function, which provides random key and nonce.
So a little bit about ChaCha20. It is a modern stream cipher that operates by encrypting data bit by bit or byte by byte, which makes it suitable for encrypting continuous data streams like network traffic. So some key features about this ChaCha20 is that there is a large key size. It uses a 256-bit key, providing strong encryption. It also uses a 64-bit nonce, ensuring that even with the same key, the encryption output is different for each message. The cipher performs 20 rounds of encryption, making it resistant to cryptanalytic attacks. It is also designed to be fast and secure. So I'm just going to go over and talk about what we have implemented in our project so far and a high-level overview of the code. So to go over the start state, we have a struct definition of the ChaCha20, which holds the two main components. A state, which is a 16-word array that represents the internal state of the ChaCha20 algorithm. A counter, a 32-bit integer that ensures every block of data is encrypted uniquely, even with the same key and nonce are reused. These values are crucial for ensuring the cipher's integrity during encryption and decryption processes. Our next bit that is important is the initialization. In the new function, we initialize the cipher with a 256-bit key and a 96-bit nonce. This involves setting up the first four words of the state with the predefined constants to identify ChaCha20. The predefined constants is expand 32 by k. Um, After that, the key is loaded into words 4 through 11, and the nonce is loaded into words 15 through 13 to 15, sorry. And the counter starts at 0, indicating the first block. There's also a new default function that generates a random key and nonce using Rust rand crate. After that, we have the meat of our algorithm. The core function of ChaCha20 is the quarter round function. The function takes four words from the state and performs a series of add, XOR, and rotate operations to shuffle the bits. The process is done in a way that diffuses the influence of each byte across the entire state, which is what makes CHA20 secure. By calling this function on different sets of state words, we're alternating between column and diagonal rounds using key stream generation. After that is the next big function that we implemented to help us with ChaCha20. The block function is where the actual key stream is generated. It works by copying the current state into a working state, then applying 10 column rounds followed by 10 diagonal rounds. After 20 rounds, the original state is added back to the working state to finalize the block. The result is a 64-byte array, which is our keystream block. Each 64-byte chunk of data will be XOR'd with this keystream during encryption and decryption. Then comes the smaller functions, the encryption and decryption functions. The encryption function takes plain text and splits it into 64-byte chunks and XORs each chunk with a keystream block. The counter is incremented after each block to ensure that the keystream remains unique. This is a critical step because it uses the same keystream for multiple blocks with compromised security. Since ChaCha20 is symmetric, our decryption function and encryption function are the same. So our decryption function just simply calls the encryption function again. After that, we have our file encryption and decryption functions, which reads data from our file, encrypts or decrypts the data, and then the outputs the result into a new file. And then after that, we have a helper function called setCounter, which allows manual control over the counter. This is crucial in cases where you'll see later, where we want to resume encryption or decryption from a specific block. Updating the counter in the corresponding state will ensures that the key stream stays in sync with the data. That's just an overview of our code. And Zihao will now take over and show an demonstration of our code.
Yeah, hi, I'm gonna go ahead and run this code to show you how it works. So basically, first I implement all the cargo basics for running the code, and after I run the cargo, it will build the project, and then I'm gonna run it. Cargo run. So yeah, the original array is taken from the input file, which is hello world smiling face, and it's gonna encrypt it out and output the encrypted array into the output text, which is a randomized string or weird characters, and up and then gonna retrieve this sequence of characters into the descripted function and output the descripted text. As you can see, it's hello world again. So that shows the function is working properly. And now I'm gonna change the input to see how it looks like. I'm gonna change it to secure byte, and now I'm gonna run it again. You can see the original array is changed, and the encrypted array is it outputs like that, and the descripted array is secure bytes again. So it works successfully. And also we used a randomized function. So that means every time the key will changes, which means even we input the same array, the encrypted array will change. So as you can have a look at the encrypted array, and I'm gonna use the same input and run it again. And you can see the encrypted array is different. So now I'll walk you through the development process of this project. Yeah, so at the beginning of this project, we did background study, which we're interested in the topic of encryption and decryption, but we are hesitated about like which algorithm to implement. Some algorithm is too simple and too not secure, and some algorithm just it requires so many calculation, so many computing resources which we are not have access to. So we chose this ChaCha20 encryption algorithm as it's um easy to understand, and it is quick and also secure at the same time. And the next challenges would be to understand the complex algorithm of ChaCha20 because it's use a complicated mathematical way of processing the data and outputting it. So basically, as Hemanth has said, it's use a matrix to add its key and nonce, and then it perform bitwise XOR and then bitwise rotation. So it's crucial to understand how this works mathematically before implement it into Rust code. So it takes good efforts in studying. And then we're gonna find how to implement these transformation into code. So yeah, that's a big part of it. And then is to implement the function of randomized key and nonce. So basically, the challenges of implementing the randomizing function is that because it's a random key, so every time the encrypted string would changes, so it's hard for us to check if it's outputting the right um the right sequence. So it's a bit harder. So we first make sure like all the program is running properly without the randomized key, and then we use the randomized function so that it works properly also. So after we implement all these, it's a lot of debugging efforts because the first is to read read the string from the file and input to the function properly, and then to output to write the file. And also it's the function itself, since it's a very complicated algorithm and there's so many variables included. So our fun like our ChaCha20 algorithm is not working well at the beginning. Like when we input a string, it's not giving out the same descripted string. So there's a lot of work in understanding uh how the data went through in the algorithm and find where it went wrong. Yeah, so that's a hard part and challenges we faced when working on this project. And that's all.
Thank you.
Yeah, thank you.